Welcome back, my brilliant students. I'm so excited because everyone is online and ready to learn. Today, we are officially kicking off Grade 9 Mathematics. Exercise 1.1. Sar Im Hussein and everyone watching, pay close attention and stay completely attentive. We are about to break down, master, and absolutely smash these math questions together. Let's get started. Section 2. Branch 1. The first question, does it stop? Let's start from the top box. All real numbers. And follow the first path down to the left. Wake up, class. This next one is the easiest mark you will get in your test. Focus your eyes on the screen. Here, we encounter our first big question. Does the decimal behavior stop? If the answer is yes, we follow the green arrow down. This means the digits come to a complete halt right after the decimal point. Mathematically, we call this a terminating decimal. Because it stops perfectly, it immediately joins the rational number family. If you look at the examples at the bottom left under the rational box, you can see 7/8. When you divide 7 by 8, it terminates perfectly into 0.875. You can also see the square root of 4. Since 4 is a perfect square, its root simplifies to the whole number 2, which is also a rational number. Section 3, branch to the second question, does it repeat? Now, let's go back to the top question. Does the decimal behavior stop? What if the answer is no? We follow the red arrow to the right. This tells us the decimal digits keep going on forever and ever toward infinity. But before we decide what it is, we must ask our second big question. Is there a repeating pattern? Let's look at the yes path first, pointing to the left. If the digits keep going forever, but repeat the exact same block of numbers over and over, we call this an unterminating and recurring decimal, even though it never ends. That steady, predictable pattern acts like a bridge, as you can see by the blue arrow looping back to the left, connecting it straight into the rational number family. Look at our repeating examples at the bottom left. We have 2.353535 repeating infinitely, and 0.6 repeating, which is written with a small bar over the 6 to show it loops forever. Because they are predictable, they are rational. Section 4, branch 3, the path to irrational numbers. Now let's head back to that second question. Is there a repeating pattern? What if the answer is no? We follow the red arrow straight down. This means the number behaves wildly, it keeps going forever, and it has absolutely no pattern. It is completely unpredictable. Mathematically, this is called an unterminating and non-recurring decimal, because it never ends and never repeats. It leaves the rational family entirely and is classified as an irrational number. If you look at the bottom right under the yellow irrational box, you can see our famous mathematical constants pi and d. Both of their decimal values run on forever, without ever settling into a repeating pattern. Section 5, branch for the special case Surds. Finally, let's look at the special path on the far right of our map, branching down from the non-repeating side. This is the case of a square root of a non-perfect square. When you take a number that isn't a perfect square like the number 2 or the number 7 and place it under a radical sign, its decimal value will automatically run on forever without a pattern. This specific type of irrational number is called a surd. As you can see from the arrows, every single surd, like the square root of 2 shown at the bottom right, automatically funnels directly into the irrational number category. Section 6, summary conclusion. So, let's summarize this entire board to make your revision easy. If a decimal stops, it is rational. If a decimal does not stop but repeats, it is also rational. If a decimal never ends and never repeats, it is irrational. And any non-perfect square root is a surd, which makes it permanently irrational. Keep this flowchart in your mind. Use it to practice your exercise questions, and you will never make a mistake. Thank you for watching. Study hard, and I will see you in our next lesson.